Today we're going to talk about piecewise functions, section 9.2. All right, piecewise functions. So continuing our talks about functions, today we're going to talk about what is piecewise functions. A piecewise function has different rules for different parts of its domain. All right, so basically when you think of it, a piecewise function, I think of it as, it's a function that's broken up into pieces. So there's different pieces about it. To evaluate a piecewise function for a given value of x, find the interval that x belongs to. Then find the corresponding definition of the function for that interval. So as you look here, I have a function f of x, and it is broken up into three different pieces. All right. The first piece says -6 if x is less than or equal to -1. So for any value that is less than or equal to -1, I'm going to get -6 back out. And then I have the second piece, says 2 if x, or if -1 is less than x, which is less than 4. So any value between -1 and 4, I'm going to get the value of 2. And then 10 if x is greater than or equal to 4. So any value greater than 4, I get the value of 10. So notice here they had three different values. They picked -5, 0, and 5. And all three of those fit into different intervals, so I had three different outputs. And that is a piecewise function. Now again, the top ones are just as easy as they are. Like some of you are like, well, it's literally -6. No, it literally is. Like if you can't plug it in for an x value, you get what you get. It's like a constant back out. Whereas the next section here, this kind of makes a little more sense to you. You're like, oh, now I see where I plug the value in because I have an x value actually. Same thing. It's a piecewise function because I have if x is less than 2 or if x is greater than or equal to 2. Notice I had -5. I have x equals -5. -5 is less than 2. So I take that value and plug it into the top function. 4 times -5 minus 1, and I got -21 there. Same thing here. I had x equals 5. Well, 5 is greater than 2, so I plug it into the bottom function now. 5 squared is 25 plus 3 gets me to 28. All right, piecewise function. The toughest part about here is just making sure you plug it into the correct function. All right. So let's look at what this looks like. Evaluate each piecewise function for x equals -2 and x equals 4. So x equals -2 and x equals 4. Number 1, I have h of x equals 0 if x is less than or equal to -3, 2 if -3 is less than x, which is less than or equal to 1, or 6 if x is greater than 1. I'm first going to do h of -2. Now, where would -2 fall into? Would that fall into the first, the second, or the third piece function? So -2, is that less than or equal to -3? Is that between -3 and -1? Or sorry, -3 and +1? Or is it greater than 1? Again, I'm looking for where it falls in place there. The first, the second, or the third one? What are you thinking? Anybody? It falls in the second one. Again, -2 falls in place right there. It is between -3 and 1. So when I plug -2 in, what is the only output I have there? I get a 2. That's my answer. Because there's no x value to plug in, I get a constant back out. Okay, does everybody see how they're all constants here? I'm going to get a constant out every time. And then I have 4. Well, which piece function would that fall into? The first, the second, or the third? That falls under the third. Again, because that is greater than 1. So when I plug it in there, what do I get out? I get 6. That's my answer. And again, those are piecewise functions, so pieces of functions. Number 2, I have k of x equals 2x squared minus 1 if x is less than or equal to -1, or 3x plus 2 if x is greater than -1. Again, these are ones that probably make a little more sense to you because you see where you're actually plugging the value in because they have an x. So I have -2 first. Does -2 go in the first or the second function? That would plug into the... Again, is it less than or equal to -1 or is it greater than -1? It goes into the first function. So I take -2 and I plug it in for x. So I get 2 parentheses -2 squared minus 1. -2 squared gets me 4. 4 times 2 is, minus 1 is, I get an answer of 7. So I plug it in and evaluate. Next, I have 4. Does 4 go into my first or my second function? That goes into my second function. All right, so I plug 4 in for x. So I get 3 times 4 plus 2. 3 times 4 is 12 plus 2 is, my answer is 14. Nice shot. Number 3, I have p of x equals 2x plus 5 if x is less than 0, or x squared minus 5 if x is greater than or equal to 0. Now, what am I evaluating for? I'm evaluating for negative 2 and 4, right? So I'm first going to do p of negative 2. P of negative 2 goes into the first function. Nice job. So that's 2 parentheses negative 2 plus 5. 2 times negative 2 is negative 4. Negative 4 plus 5 is, I get an answer of 1. And then I plug in 4. So I have p of 4. That goes into my second function because it's greater than 0. So that gets me 4 squared minus 5. 4 squared is 16 minus 5 is, I get an answer of 11. And those are piecewise functions. And again, it's functions broken up into separate pieces depending on the domain. All right. Take a couple seconds to try these 4. Again, recognize you are evaluating each piecewise function for x equals negative 3 and x equals 4. Take a couple seconds to try those 4. All right, let's look at these here. Number 4. If I plug in negative 3, that goes into the top function. 4 would go into the bottom function. And what do I get for answers there, Jack?
4.
Yep.
Negative 3, 4.
10 and negative 1. Because there's just the constants there. Sorry, there's nothing to plug in, I just get that out. Number 5, negative 3 would go into the first function, and 4 would go into the bottom function, or the last function. When I plug it in, what do I get for answers then, Andy?
Negative 10 and negative 3.
Negative 10 and negative 3. Nice job. Number 6, negative 3 would go into the first function, and 4 would go into the third function. And what do I get when I plug those in, Maddie? 5 and 2. And number 7, negative 3 would go into the first function, and 4 would go into the second function. And I get answers of what, John?
Negative 12
Negative 12 and
and 30.
28. Nice job. Again, when they have a constants there, you just get those constants back out. Don't make it tough. The x's kind of makes it seem easier because you see where you're plugging it in. But if it's just constant, you get that constant back out. All right. Last thing we're going to do today is we're going to talk about graphing these piecewise functions. So you can use a table of values to graph a piecewise function. Now recognize, again, piecewise function, pieces, I have different functions. So here's my function. I have f of x equals 2x plus 4 if x is less than negative 1. And I have f of x equals negative x plus 3 if x is greater than or equal to negative 1. Notice, what value did I start at here to kind of graph in the middle? I started at, because that's where my pieces were interrupted at, I have to do negative 1 for both functions. Now, why do I do it for both functions? Because one of them, again, think about back in like junior high when you graphed on number lines or pre-algebra. You have the open circle or the closed circle. You get the open circle for the less than or greater than signs because you have everything up to that number. The closed in circle for the less than or equal to or greater than or equal to signs. Okay? So I started at negative 1 there. And again, I chose less than. For the less than values, I did 2x plus 4. And the greater than values, I did negative x plus 3. And again, from there, I plug in the coordinates and I plot them to make my lines. And again, notice my lines kind of look like they're slightly different because there are different functions within those pieces. Okay, so let's try number 8. I have g of x equals negative 2x if x is less than or equal to 1, and g of x equals x minus 4 if x is greater than 1. What value do I want to start at first for both of them? I want to start at 1. Again, why am I starting at 1? Because that's where those intervals are kind of broken up. So I plug in 1. Let's do the less than first. So -1, we're going less than for g of x equals -2x. When I plug in 1, I get -2, right? Okay. Am I going to have a solid or closed circle there? Again, looking at my inequality here. That's going to have a closed circle. So there's a closed circle at 1, -2. So I plot 1, -2. Closed circle.
Did you say solid or closed?
Solid, closed, either way. I guess I use both terms.
Yes.
Yeah, 'cause I yelled solid because I was like, oh yeah, that makes sense. And then you both said closed. I was like, wait.
Either way, I guess. I guess this one says closed and open, solid. I don't know. Yeah, it's the same. So then I go less than. So what do if I plug in 0? What do I get? 0. So I plot 0, 0. If I plug in -1, I get. If I plug in -2, I get. So I get -1 and 2, and -2 and 4. And my graph's going to keep going like that. Now I do positive 1 again by plugging in my other function. What's 1 minus 4? Will that one be an open or a closed circle? That is an open circle at 1, -3. So open circle at 1, -3 there. And then I go greater than. So I plug in 2 and I get. I plug in 3 and I get. I plug in 4 and I get. Okay, so I have 2, -2, 3, -1, and 4 and 0. And my other function looks something like that. Notice in the value they share, I have an open and a closed circle on that value. Okay, because the one that's going up to the left means the one's included. The one that's open means that one is not included, but everything up to that value is. Okay, and again, recognize the values that they share, I have to do for both. One of them would just be an open circle, one would be a closed circle is the difference. Okay, let's try number 9. F of x equals 6 if x is less than -2. F of x equals 3x if -2 is less than or equal to x. So first thing I want to do is I want to make a table. What value do I want in the middle of that table? I want -2. And again, why is it -2? Because that's what they share. And then I'm going to go less than -2, which is -1, or sorry, -3, -4, and -5. And then I go greater than -2, and I get -1, 0, and 1. Okay. Then I plug my functions here. I have 6, and I have 3x. If I plug in -2 for the, let's do the 6 function first here. Let's do that one first. What do I get out? If I plug in -3, what do I get out? If I plug in -4, what do I get out? If I plug in -5, what do I get out? If I plug in negative infinity right there, what do I get out? I just keep going, right? So would that be an open or closed circle at -2, 6? This one has an open circle. So I have an open circle, and everything is at 6. That is like a horizontal line, because it's like saying y equals 6. It's that graph. Okay? Do the other part on your own. Take a couple seconds to try the other half of this graph on your own. Okay, let's look at this here. If I plug in -2, what do I get out? -6. If I plug in -1, I get 0, 1. So I have -2, -6. Open or closed circle now? Close. And then I go -1, -3. 0, 0, and 1, 3. And this one gets a line that we're going to go up like that. And that is a piecewise function. Nice job. Take a couple seconds. Try number 10. Again, as you look at your graph, you have to make a table. What value do you want in the middle of that table?
5.
Yeah, you want to put 5 right in that middle of that table. All right, try those. All right, so let's look at this one. When I plug in 5, again, I start with 5. What do you get for the 12 minus x function?
Really confusing.
Huh?
I was trying to use different.
Let's do the 12 minus x function first. When I plug in 5, what do I get? 7. All right, so let's go up then, because I'm going less than. When I plug in 4, I get 8. Plug in 3, I get. Plug in 2, I get. So I plot those coordinates. I have 5, 7. Now again, that was a closed circle at 5, 7. And then I had 4, 8, 3, 9, 2, 10. I gotta get a line that looks something like that. Well, let's plug in 5 for my other function now. What's x plus 2 gonna give me? 7. Huh. 8, 9, 10. But this one has an open circle, right? So technically I have an open circle there. Does it matter? No, because it's the same one, right? Yeah. But then I plot the other coordinates, so I have 6, 8, 7, 9, 8, 10. What letter does this kind of look like? It looks like a V. This actually is technically what an absolute value graph would look like in a sense. Okay. But yeah, it makes a V there. Nice job. Not a parabola.
Parabolas have curves.
I know.
Thank you. Good recognition.
The standard.
Fun fact about parabolas.
Here is your assignment.